30. Are you ready to get started?
Ready.
Okay. Folks are still kind of joining, but we're going to go ahead and get started. Thank you everyone for being here for HMSC's research seminar. My name is Cinnamon Moffitt, and I am the research program manager at Oregon State University's Hatfield Marine Science Center, located in Newport, Oregon, and I will be your host for today. I wanted to just take a little pause from our program though before we go any further and just kind of recognize that today is a hard day. With the escalation in Ukraine, personally, I find that I struggle between being engaged and being completely overwhelmed. So I just wanted to take a second to thank everybody for being here and being part of this community where we take a moment to recognize and learn from those that work hard every day to make the world just a little better place. And so I am thankful, especially today, that we come together and find community in this way. So thank you for joining us. Okay. Back to logistics. You've probably heard these before from me, but we do have your mics, cameras, and screen shares turned off. Go ahead and leave them off for us at this time, and we will get to questions at the end. Please put any of those questions into the chat box, and we'll work through them when we get through the presentation. And if you have a complicated question, go ahead and raise your hand, and if we have time, I'll call on you and I can unmute you and you can ask that question verbally. Also wanted to let folks know that we are recording today's session and it will be posted in the chat where that link is at, which I'm trying to put in right now, which it's not letting me do, but I'll work on that here in a second. That you can go ahead and get to that recording here in probably 2 days or so. So if you want to share this with others that aren't able to join us today, please feel free to do that. Wanted to make a little announcement for next week's seminar. It is March already, everyone. March 3rd, Emily, a postdoc with NOAA's Alaska Fisheries Science Center, is going to be talking with us about climate change impacts on the important fishery species and fish pathology. So hoping that you will join us for that. And if you need the links to any of our events, you can go to HMSC's homepage, scroll to the bottom, there's a calendar of events there. And if you click on any of the events, you'll get a link so that you can log on to any of our events. Little plug, I've got 2 more days of seminars that are not booked for spring. So if you are interested in giving a seminar or want to volunteer somebody to join us, let me know who they are and we'll try to get them on our spring seminar calendar. But for today, just a little bit more about our speaker. Evan Hayduk is born and raised in Western Washington and has spent his entire career dedicated to restoring natural systems in the Pacific Northwest. After completing his undergraduate at Santa Clara University, Evan returned to Washington to complete 2 AmeriCorps terms with the Washington Conservation Corps and received a master's of environmental studies at the Evergreen State College. He has worked in various ecosystems, from work in estuaries and riparian zones to prairies in the Oak Savanna, and spent 3 seasons growing plants for the subalpine meadows for a restoration project in Mount Rainier. Since 2016, Evan has been the council coordinator for the MidCoast Watershed Council, working with partners to complete major restoration projects in the council's nearly 1 million acre footprint on the coast. When he's not working for the council, you'll probably find him in his backyard veggie garden, walking with his dog and his wife on the beach, or you might not be able to find him at all, he tells me, because he loves to spend time backpacking and camping in remote locations all around the world. So Evan, we're excited to have you here to tell us a little bit more about some of the restorations projects you've been doing here locally. So I'm going to hand the mic off to you. Before I do that, I just want to let folks know that Evan's going to turn his camera off here soon so that internet connection will be a little bit more stable, but Evan, go ahead and take it away, and thank you for being here.
Thank you, Cinnamon. And as she said, I just wanted to say hi so you know who's talking to you, and then I will turn off my camera now, just so I don't have any legs here. And yes, thank you, Cinnamon, for that note about Ukraine. I was thinking about saying something because I think it's all on all of our minds, and I'll try to focus on this with all the bad that's going on in the world right now, but maybe this 45 minutes we could just think about this and some of the good that we've been doing here on the coast. So again, Evan Hayduk, Council Coordinator for the MidCoast Watersheds Council. My hope with this presentation, I think it's a little bit different than a lot of these seminar series, some of which I've seen here at Hatfield. I really want to not only just share the work that we do here at the MidCoast Watersheds Council, but really have this be a start of a conversation with the Hatfield community and researchers there to talk about how you all can get more involved in the work we do, and how we can foster collaboration between our group and all the groups and agencies we work with, and kind of build our our umbrella here of work on the Midcoast, and how we can all kind of maybe get more activity from the Hatfield community in the work we're doing throughout our watersheds as well. So let me make sure I can advance my slides. There we go. Just wanted to give you an idea where we're going today. I'm going to talk a little bit about Midcoast history and how the Watershed Council came to be, think a little bit and discuss a little bit about our historical perspective of what our landscape looked like, and what our current conditions look like as well. Talk briefly about our restoration mindset, and how we really try to restore watershed scale processes, and how we go about doing that. Share some examples and of the types of restoration work that we complete here at the council, and then take a deep dive into kind of two of our projects, especially the Yaquina Tidal Restoration Project, to talk about some collaboration and how kind of show you how much work goes into actually getting these projects on the ground, and highlight the Mill Creek effectiveness monitoring work to show how a really good example of an interdisciplinary collaboration that is really answering questions, some of the questions that we have about the work we do. And you'll hear me say we a lot here, and that's a big umbrella we. So when I say we, it's us at the council, it's our whole board, which is a diverse board of interests here on the Midcoast, and it's also all of our state, federal, local partners, everybody. You guys are all a part of that. We definitely can't do it just ourselves here at the council, and we rely on these collaborations to get all this work done. So MidCoast Watersheds Council started with public meetings in 1994, and we were officially incorporated as a 501c3 in 1996. From the Oregon Plan for Salmon and Watershed in 1997, was pretty much divided into kind of varies 60 to 80 watershed councils of varying size, all throughout the state, to kind of get everyone in these little areas together, really have a broad, diverse set of at the table to work on these projects and help to restore these watersheds, and at that time kind of address the real crash in commercial salmon production and salmon populations. We're a little bit different than a lot of watershed councils. We cover a big area, as it was mentioned there, almost 1 million acres here on the coast. We have really 4 or 5 major, pretty large systems, from the Salmon River up north, Siletz River, Yaquina River, Alsea River, and the Yahats, and then all the direct ocean tributaries along the coast, including Beaver Creek down to 10 Mile Creek, and pretty much everything Heceta Head to Cascade Head that drains to the ocean. That's our quote unquote turf. And we overlap with some smaller watershed councils up north, the Salmon Drift Creek Watershed Council, and historically have worked with the Siletz Watershed Council, some basin planning teams in the Yaquina and the Alsea Watershed Council, which recently stopped operations, and we're picking up some more work in the Alsea to fill that void. So really important to, when we're thinking about the work that MidCoast does, is to have a historical perspective. And I think we've all heard stories of old timers saying, you used to be able to walk across the backs of salmon in our streams. And that's probably not much of an exaggeration of these, salmon runs. It used to be millions and millions of fish. And, what those fish had at the time were just pristine habitat conditions. There's no man-made barriers, no culverts to get through. Our watersheds were full of old growth forests that just dumped tons of large wood into our streams, which are really vital for a lot of our systems that are sandstone, easily erodible. They need that large wood to really maintain complexity. Beaver dams would have been everywhere before they were really heavily hunted in the 18 and 1900s. And this natural productivity, we know our landscape is capable of it. But we know we're working from a fairly shifted baseline of what it looks like out on our landscape from what it used to be. And that change is, this transition from, old growth as far as the eye can see up and down the coast to a lot more young, even age stands throughout the Coast Range and wider. And this is not meant to be a dig at the timber industry at all. We work with a lot of interest in the timber industry. A lot of Oregon's economy is, based on timber production. And I'm not here to rag on the timber industry. There are partners in this work. I'm just presenting what it looks like on our landscape compared to what it has in the past. So this changed landscape for streams and rivers means that we've gone from complex stream networks with large wood, just choked with large wood, good cover, really good fish habitat, to simplified channels due to myriad reasons: splash damming, beaver trapping, agricultural practices, actual removal of large wood from streams, which was occurring all the way up through the 1980s. And this has really just degraded the habitats in our watersheds. Loss of spawning gravel, loss of floodplain connection, and really just a changed landscape from what it was. This slide always makes me think of Wayne Hoffman, who a lot of you may know was our longtime coordinator and policy director, and he retired in 2018 and moved all the way across the country to North Carolina. He always liked to say that a messy stream is a healthy stream, and it's really true. And a lot of folks think of a farm pasture with a stream running through it, and what we end up with a lot of times is just not very pretty poorly functioning streams in a lot of areas, not just farmlands. But lack of riparian cover, lack of large wood in the stream, eroding banks. Maybe we do have some buffer, but maybe it's a one tree buffer that puts some shade on the stream, but isn't a complex multi-level canopy that really creates a microclimate that really will keep stream temperatures down. And these poorly functioning streams really just add to this changed landscape. We've gone from cool, clean, oxygen-rich waters, which is good for us, good for fish, good for everything else. And what we have now is warmer streams, 303 delisted streams by DEQ, streams that have high sediment loads, streams that have dissolved oxygen issues because of they're being choked out by invasive species. Tends to be more landslides, debris flows. Our wetlands, tidal marshes have been filled or altered by dikes or other activities in the last 150 years. Just miles of roads and culverts, and not many dams on the mid-coast, but there are a few. But all these kind of add up just to barriers to passage for these historic salmon populations and stream habitat. And like I mentioned, the Tyee sandstone formation, which is what most of our streams are, really need that large wood in there to hold on to spawning gravels, to not downcut or incise the stream when you don't have the wood in there. And that we know that floodplain connection with streams is really important for fish to get off, get out of the main channel during high water and survive higher flows and then get back into the stream. And when get channel incision, you get these degraded conditions, you just lose the ability for fish to be productive. So it's a daunting task to think about restoring this and have that historical perspective. But what we really focus on here at the council is holistic whole watershed restoration, and a real focus on restoring the processes. So we're not having to constantly do this work. We're hopefully at some point 50, 100 years down the road, putting ourselves out of work if we can kind of set up these natural systems to restore these processes that maintain these stream systems and watersheds for thousands of years. We're working all throughout the basin. A lot of work in the early days was focused in these wadable streams, but these higher reaches. But we've and always have done work throughout the whole watershed. So up in those tributary streams and middle reaches and main stems, larger tributaries, and a lot of work down in these fresh and salt marshes, estuaries, and even out to the near shore. And some of that kind of shift in thinking has really been driven by the research into the coho life history diversity that's come out of the Salmon River estuary up north, and some other areas that show that that 10% of what we call nomads in the past that used to not even be counted in our assessment math. We think, oh, they got washed out prematurely, they're gone, but people actually followed them down the Salmon River. They found them in the estuary, they found them in main stem, they find them getting into other tributaries that aren't their natal stream. And we know from the Salmon River that 10% contingent can actually represent 30 to 40% of the returning adults, because they're expressing this life history pathway that in a lot of cases has been blocked off. So opening up these pathways and letting these populations express their full life history diversity is a real goal of our work, to really build not just be focused on numbers of fish, but really building a sustainable, resilient population. So just briefly want to mention a couple of types of restoration projects we do. So culvert replacements, large wood placement in stream, a lot of vegetation management. We're absolute advocates for beaver and living with beaver where we can on the landscape. We certainly understand beaver don't work everywhere where they're damaging roads or housing or other infrastructure. They can be an issue, but we encourage folks, if you can live with beaver on your landscape, and we offer these pretty easy tricks and some tools to work with beaver, and beaver do our work better than we could ever hope to do. So anywhere we can get beaver on the landscape, we know that's good for salmon, and we know that's good for a lot of other species as well. Some of the more intensive work we do are getting streams back to where they want to be from where they were altered in the past, floodplain reconnection, floodplain grading, and also estuary work. And I'll share some examples of that here soon. And a real piece I'm going to kind of focus on as I'm talking here is this monitoring element. We, of course, monitor the work that we do. We have certain requirements from our funders to do that, but the real point of our monitoring is to really assess, what we're doing and learn from it, and see what we're doing well, see what we're not doing as well. And the next time we do a project like that, have some lessons learned and have some recommendations to change maybe what we're doing or how we're doing things. And monitoring money is not easy to come by. We usually get some on our grants that we work with, but we really rely on partnerships and collaboration with folks like you, researchers and grad students and even undergrad, to do and help us with this monitoring work. And that's an ongoing need that's just going to be continuing. So that's my first little plug for how I think we can interact a little bit more with you folks as well. So just some examples of, culvert that were installed, a lot in the early 1900s up to 1950s. No one was thinking about fish passage at these. They were thinking about getting a road across the stream to get to a timber harvest or whatever it is on the other side. And these are issues for fish passage. They can be velocity barriers. Juveniles can only jump about 6 inches. So if you have a juvenile that's trying to reach cold water refugia and they hit a culvert that's perched a foot, they won't be able to get by. Any perch will be a barrier to lamprey. They have no ability to jump like a salmon does. Fish passage is an issue, but also these culverts really affect stream morphology, both at the culvert site itself, but downstream from the culvert, you can get a blowout that kind of can erode the stream down to bedrock because you get a Venturi effect of that stream water fitting through a small culvert. Upstream effects, it's not just limited to the culvert itself. This is one of the first MidCoast projects, OEB funded MidCoast projects on the school fork of the Yachats in the late 90s. And clearly the damaged culverts on the left there were probably a velocity barrier at times and threatening to wash out and then cause more issues for the human side of things with the roads. So a grant was received to put in a bridge, and bridges are obviously preferred. You have full spanning bridges that you're not trying to put all that water through a little pipe. So this is the kind of work that MidCoast has been doing since the late 90s. And this is an example of a project we completed in 2020 on North Creek up in the Select system on Forest Service property. You can see the culvert there is about 11-foot round culvert on the right side. The stream itself is about 30 feet wide, so it's about 1/3 of what we call bank full width, which is just the kind of normal winter flow. And our standard now that we shoot for is when we put in a new culvert is 1.5 times bank full width. So this was less than 1/3 of bank full. In 2019, MidCoast and partners put in this 50-foot wide culvert at the site, and culvert projects, fish passage projects are one of the projects that we sometimes get a little instant gratification. Downstream from this culvert previously had been blown out, all the spawning gravels, and we had spawning gravels accumulating the winter after we finished this project, and had Chinook and coho both spawning in that reach and even underneath the culvert itself the first winter after we completed the project, which that little bit of instant gratification does help sometimes in motivating us to get some more work done out there. We do, like I said, large woody debris placement. This is a little bit of a band-aid. You're not restoring the process of growing trees that fall into the stream and act as grade control. This is a little bit of a 20, 30-year treatment that we can get some wood in the stream and maybe have to retreat it as we're building up these conifers in the riparian area for that long-term recruitment of large wood. So it's a good and bad with logging roads all along our streams that we do. That does open up a lot of access for large equipment to be able to put wood in streams with ground-based equipment like this log loader here. Portions of our watershed do not have roads, which is overall a good thing, and we do have done helicopter-based treatment, and it's pricey. You're paying for a helicopter to fly logs around, but you can do full trees and reach areas obviously that you couldn't reach with ground-based equipment. So vegetation management, this is kind of one of those longer term process-based restoration ideas of 50 to 300 year timeframes of getting large trees, mostly conifers, established in the riparian area. That's our bank account with large wood. That those trees will grow up, they'll shade the stream in the short term, and in the long term, that's what's going to be what's falling into the stream or even falling in the floodplain and acting as a nurse log and growing the next generation of forest. And we work in wetland areas, riparian areas. We work in some upland areas. We have a real focus, like I mentioned, on conifer establishment, but also plant a pretty diverse suite of pollinator species. So flowering shrubs that are really good for birds and bugs and bees and everything, and kind of mimic, a natural forest, multi-canopy forest is what we're really going for. And more recently, we've really been looking at these for the carbon storage idea, this idea of co-benefits of we can store a lot of carbon in these areas. I think one paper suggested we can store up to 30% of the carbon that we need to store in just our riparian areas. So that's kind of an emerging idea of this carbon storage, and we think this is a big part of that picture. I just wanted to point out this field here in the upper Yaquina was just choked with reed canary grass. You can see the crew assessing it there. This is that same field 10 years after planting, and just a major change from a little bit of funding and a little bit of effort to get some native trees established above that reed canary grass and really start to restore the riparian area. Mentioned living with beaver. It's a big focus of our planting. We put their food material that they like to eat out there. We put their dam building material that they like to eat. We really believe that if you build it, they will come. We know there's good, decent beaver populations, and they disperse very well. So we just focus on setting the conditions for them to be in these areas, working with landowners to do, pond levelers or different types of somewhat cheap techniques to live with beaver and deal with beaver, so they're not blocking a culvert and they're building a dam set back from a culvert. And yeah, we know beaver are really important. Like I said, they do our work better than we do, and federal coho recovery plan says, hey, if we get more beaver on the landscape, that's really going to help, and that's part of our work is really trying to push that and get more beaver where people can tolerate them on the landscape. A little bit more heavy-handed approach is some more like stream repair, or getting a stream back where it wants to be from where it's been altered, floodplain reconnection work, and estuary work. I'll highlight this project, our Yaquina Tidal project, which is images from next. So another example of big floodplain restoration project is one we completed down on Big Creek, down at Washburn State Park in Lane County. It's hard to tell, but this creek, Big Creek here, is about 12 feet down from this unnatural fill, which is actually an old ODOT landing site that this photograph is taken from. And this project was a big collaboration between ODOT and state parks and Forest Service and a whole bunch of other partners. And we went from this simplified in size channel to a much messier and thus much more habitat friendly Big Creek, and have seen spawning through that reach as well in the 2 years since that project, and a lot of good benefit from that project already. Again, here's the monitoring piece. We've got a couple big projects, big monitoring efforts up on Green River, up in Five Rivers, and I'll highlight next the Mill Creek Siletz effectiveness monitoring. We've really relied on our partners from the Lincoln Soil Water Conservation District MidCoast Monitoring Program for our monitoring help. They follow ODFW protocols for aquatic habitat inventory, and we really like to do that before we, for instance, put wood into a stream, so you can quantify the habitat. Say this is with a picture before our project, complete the wood project, and then do hopefully a year 1 and year 5 or year 10 project afterwards to really see if you're boosting the habitat, and if you're reaching your benchmarks for how much wood you got in the stream, and if that's really having a positive effect on fish habitat. So that's kind of the background. I'm going to dive into our Yaquina Tidal project now. This is just upstream, about a mile upstream from Toledo on the Yaquina River. If you know where Mill Creek comes into the Yaquina there, you can see it on the bottom of the screen. It's a 55-acre property owned by the Wetlands Conservancy. And this project in 2020 built off of previous work at the property in 2001, which breached the perimeter dike that runs all the way along the river in 5 locations. They filled some linear ditches and excavated some tidal channels. And in the 20 years since that project, we learned a lot about estuary restoration and about how to do this type of work. And the original project was one of the first funded by the Oregon Watershed Enhancement Board in 2001. And it was an opportunity to revisit it with a willing landowner and really kind of be a little more intensive about dike removal and really trying to get to more goals of really restoring the full hydrologic connection between these adjacent marshes and the Yaquina River, open up as much of this area to fish passage and rearing area for these salmonids and other species, and get more wood back into this estuary, which all these estuary areas would have been just chock full of wood back in the day. And a focus of this work was also really trying to focus on scrub shrub and spruce swamp habitat, which in 2019 Laura Brophy report about the loss of scrub shrub and spruce swamp habitat on our landscape was pretty daunting, that 80 to 90% of these type of habitats are gone. And that informed our design through the process as we were working on the design, which I'll highlight here in a second. So our objectives and the project elements I've kind of mentioned here: dike breaching, being a little more, instead of just creating a notch in a dike, lowering whole portions of the dike so you get more sheet flow across the site. That sheet flow is what really drops out those sediments during high water and relieves that process of accretion. And that accretion can build up and actually keep up with some sea level rise estimates for some time. Some more tidal channel excavation, filling linear ditches and creating more sinuous paths, a focus on tidal scrub shrub habitat, and some thin layer placement. So obviously the site had been cut off by that dike for so long that it's subsided. It hasn't had that input of sediment. So all our cut fill was balanced. So we didn't truck any material from that dike removal. We kept it all on site, either as thin layer, 6 to 12 inches of placed across the marsh surface to kind of help, rebuild that marsh accretion, but also the creation of these kind of islands of an ecotone slope that transitions from high marsh to scrub shrub to where Sitka spruce can establish, to really just build resiliency in the vegetation out there as well. Wood habitat structures, a little bit of debris removal, just old tide gates, old culverts, old material from the site, and partnership with the city of Toledo to do some water line protection, because their source water pipe from the Mill Creek Reservoir runs right through the western portion of this. So not having a detrimental effect on their very important, obviously, source water, while we are trying to boost the kind of habitat on the site. And this is just a glimpse of the we that I mentioned. It takes a lot of folks to do this. I really see us as a watershed council as kind of the glue between all these different organizations, getting everyone in the same room, getting everyone involved in the planning and design of this, working with the Forest Service and Bureau of Land Management for log donations for that large woody debris, working with private landowners through our salvage log grant to get suitable wood material for these type of projects. And then obviously all our funders are a big part of this. And this is the we that I'm talking about when I say we. So this project, we always lean on a couple kind of older documents from the late 1990s and early 2000s for our prioritizations. We have a lot of more recent, obviously Coho Conservation Plan for Oregon and the Federal Recovery Plan that are pointing us to where we want to work, but we still rely on this 1999 estuarine wetland site prioritization and our 2001 six-field assessment to inform where we work. And that really helps us because these grants are very competitive up, in our region, our North Coast region of OWEB. So we need to, bolster our applications and show that the work in these areas has been prioritized. And these are the documents that we lean on for that kind of evidence that work here will have, good bang for our buck. Project funding, I'm gonna try to get rid of this for you, sorry. There we go. This is a big piece of it. So we write a lot of grants. This had two phases, obviously. The design phase, we got a technical assistance grant and some funding from U.S. Fish and Wildlife Service. And then the implementation funding is the bigger piece. So $435,000 from OWEB, some contribution from U.S. Fish and Wildlife Service Fish Passage, a PMEP, Pacific Marine Estuarine Fish Habitat Partnership Grant, and an Oregon Wildlife Foundation grant. The grants are great. The lifeblood of how it's done. What really drives us is this in-kind labor and materials from our partners. Most of these grants have a match requirement, so we need 25% for OWEB grants, and we have to come up with 25% either cash or in-kind contribution from outside organizations. And this in-kind contribution from all these different groups is really what helps us leverage this grant funding. So all these groups are a part of this work. They're for instance, the Siletz tribe is a partner on this project, and they're doing pre and post project fish surveys at the site to see what the fish use was before the project and what it was after. And these are just vital contributions to this effort that helps us leverage more grant funding to get more work done. I'm not progressing. There we go. So just quickly, the design process after we've got that first kind of chunk of design money. It was about an 18-month process. We have contract engineers that do site surveys and then do a pretty iterative process of a preliminary design, offer up some alternatives, and we kind of have to weigh what we think we can get funded and what we can do, and through that alternatives assessment. And the way that we do that here at the council is work with what's called our MidCoast tech team, which we have monthly meetings. This is my second plug for you guys to all get involved. These are open to anyone who wants to be a part of these meetings. It's where we bring like these preliminary designs and get input from agencies and local folks. But it's not just our projects that we share at these meetings. Anyone can bring agenda items to these tech team meetings. If you have something you want to brainstorm or have ideas that you want to talk about a project and want input from kind of local experts and technical folks, please contact me and we'll put you on a tech team agenda. We have them every month, third Thursday of the month. And that's what all our design processes go through. So we're getting really good feedback from local folks and the people who know these projects to really make strong projects. In our design process, we also build in permit application assistance from our engineers. You'll see the list of permits for this project next, which is a long list. It's also really important during the design phase to work with regulatory agencies and kind of vet some of these known or novel restoration techniques through the agencies before you're have a final design and then maybe end up with a design that you may not be able to get permitted. So incorporating lessons learned from similar work is also very important. And one exciting thing there is our work with the Oregon Central Coast Estuary Collaborative. where we're sharing information and sharing a lot of knowledge between all these groups working on the mid-coast and up north, and really learning from the work we're doing and building our knowledge base from all our shared experiences doing this work. So here's the designs we ended up for this Yaquina project. You might hear me call it Y27, by the way. That's just the site name. This is the end result of all that process of going to tech team, getting updates from our engineers. Once we have a good design in hand, we work on permits, and I try not to use acronyms in these type of slides, but I had to for this one just to fit all the permits for this project. It's a long list. This is a whole nother process in and of itself, getting these projects permitted. It's about a 6 month to 1 year and can be up to 2 or 3 years for some of these estuary projects. It's a lot of work, and I'm not going to turn this into a complaining session about permitting, because it's all very important, because all these agencies, state, local, and or state, county, and federal agencies are, they know we're in it for the good. We're trying to make fish habitat, but they're just making sure we're not having any detrimental effects on neighbors or anything else. So it's a lot of work to get all these submitted, but once it's a pretty good feeling to get them all done, and then we get to the fun part, which is the actual construction. That's up to this point 3 or 4 years of work. Oftentimes, like a big project like this can take months, but we've had projects that take 5 years of planning and funding and permitting, and the work's done. The actual on the ground work gets done in about 5 days. For this one, it was about 2 months of work, mostly because it was a pretty challenging site to work on. We had a request for bid process for the work itself, and went with a group called BCI Contracting out of Portland. Part of the reason we went with them is they have this specialized equipment. So this is an amphibious excavator that does actually float on the water. But when it's working on a marsh surface, it just was really beneficial and sped up the work, because those large pontoons spread out the weight of the machine. So you're not rutting the marsh surface, you're actually just floating right on top of the vegetation. And otherwise, if we were using standard excavators, you have to use, a series of large pieces of wood, of oak mats, and move those. And it's just slow and tedious. And a big part of why we were under budget and on time with this project is because this group had this specialized equipment to get this work done. They did install a temporary dock, and this is how we moved all the large wood during high tides around the project site. This was one of the permit needs, because we needed a special use or a temporary access permit from DSL for putting a bridge or a dock into Yaquina River. But we would not have been able to move wood around the site, or it would have been painstakingly slow if we were not able to kind of float wood around and use kind of barges to do that. Like I mentioned, working conditions were very hard on the site. It's a marsh. It's wet even in the middle of summer. We had to work around the tides, do a lot of the excavation work at low tide, and then kind of knock off when the tide came in. The dike lowering, here's a picture from the top of the hill of that big machine working. We ended up removing about 60% of the perimeter dike and left portions of the dike intact that had been planted in that 2001 project that had established spruce. So we left some of these portions. We opened up quite a bit of the areas, and then looked at reference marshes nearby to get a gauge of that elevation along that what you'd think of a natural levee along the river. And then we built some variability in that elevation. So we didn't just pick 9 feet and say the top of that dike's going to be perfect at 9 feet. We kind of built in a little, variation between 8.5 to 9 feet, which is what we saw a lot of at these reference marshes. So all the material, like I mentioned, the cut fill is balanced. So where we took down lowered a dike, we either did thin layer placement right around that area to make it an efficient process, or built up these kind of spruce and shrub established areas to kind of create that ecotone slope that as vegetation established, it will create the elevation gradient that supports high marsh up to scrub shrub. And then the top of the former dike is able to grow spruce trees. And this is kind of cool because this was right after the dike was lowered. We had a high tide, and you can see the tide got in, and we could kind of see pretty quickly how much more inundation and sheet flow we'd get at the site right after that dike was lowered. We did do one large new dike breach with a pretty massive tidal channel to just get more inundation onto the west side of the project. There was not a dike breach in this area from the previous project because the source water pipe was running right through there, and it was unknown exactly where it was, but working in collaboration with the city of Toledo, they did some survey work to find out exactly where it was, and that opened up some more ability to do some more work like this. And this is another one, you get some instant gratification. As soon as we took that plug out, tide came in, and fish moved right in. We saw within a month, we were seeing fish using these areas, this new tidal channel, this new dike breach, and opening to get more water forced onto the marshes of the site. Did a little bit more tidal channel network work than in the previous one. From the previous project, we had a little bit of a lesson learned that they did some kind of pilot channels, hoping that those would kind of, erode on their own and develop, but because of past compaction or, whatever it is from the past land use, didn't get a lot of down, cutting into these tidal channels. So we were a little more heavy-handed and a little more aggressive, if you will, with creating these tidal channels at the site. There's another tidal channel there. And then a big piece of it, like I said, was getting as much wood out there as we could, and putting log structures on the site, that the different types of log structures that had different purposes. So one type is these are for birches. We drilled holes in them for nesting birds, and stuck some kind of complex, gnarly looking branches and trees into the ground, and had barn swallows and kingfishers perching on those within a week of those being installed. Floodplain habitat structures, so kind of just piles of, this is a spruce that was growing in the dike, and a portion of the dike we lowered. These will help capture sediment. They'll provide cover for bugs and birds and other species. And you can see they kind of work with a couple snags there as well. Full spanning tidal channel jams and keyed logs. The keyed logs are really important to make sure this wood is staying there and it's not getting mobile and floating around. And these full spanning jams with trees that have branches are really good for fish, for cover, for hiding spots, to get away from those kingfishers that are using the snags. And bank structures as well. So instead of a hardened surface of riprap, we're using natural material of wood to kind of where we want to kind of harden the surface a little bit. This was an old ditch that outlet to the river that we didn't want to erode because it was right where the source water pipe daylights from where it goes under the river. So kind of hardening that, but in a natural way, instead of dumping a big load of riprap. The final piece of this project was the source water, or the water pipe protection. Again, riprap was considered, but instead we went with some fabric material that was pretty painstakingly laid across the marsh surface, or the ditch surface here around their water pipe. And then this kind of geotextile type fabric was laid down just to limit any erosion at the site from the hydrological changes that we're expecting from the new breaches and all that. And you can see Inca there, our one of our restoration technician dogs. She did a great job of holding down the mat while they were drilling in the staples. Just another good example of a collaboration, interspecies collaboration to get our work done out there. I lied. One more piece. The revegetation out here is ongoing. So we're doing a little bit of where spruce and crabapple and some of these scrub shrub type species can establish, and willow species, and a big thanks to ODFW and Derek Wilson. They're driving our boat because these sites are not accessible by a truck. So the only way to get plants out there and our crew out there was having Derek help us. So a little bit of before and after drone imagery, and I'm a little behind, so I'm going to go through this pretty quickly. You can just see this main north-south ditch I'm kind of focusing on for the before pictures. Very linear feature. Obviously, some tidal channels had developed off of that, but pretty limited in size. This is post-project now. You can see that new large dike breach, leaving portions of higher ground, and just a lot more inundation just from the first few high tides onto the site on the east side here, and a lot more inundation on the west side, which had not seen much sheet flow or inundation during even very high tides out at the site. Just another image of that old portion of the ditch. This is during a king tide, the January after our project. The site did flood through those original breaches at a tide this high, but now with those, you can see the openings in the spruce trees there. Just much more sheet flow, much more chance for those sediments to drop out during a storm event, during king tides, and help build up the marsh level there. A few more pictures here, and a low tide picture of our tidal channels and some of our wood structures as well. So monitoring, I'll be brief here. We have obviously photo monitoring at the site with ground-based and drone imagery. I mentioned the tribe is helping us with the fish use. We have long-term transects at the site for vegetation, which we're excited to kind of monitor and see how that changes over time. We'll do cross-section analysis of the channels to see if they're developing. We'd hope to set up sediment accretion monitoring at the site, but haven't been able to, and that's has asterisks around it because that is just waiting for a grad student to take that on and do a couple year study of feldspar marking or some old school techniques of sediment accretion, and just trying to again just put a pin in it, and this is an ongoing need both at this site and all our projects, and that's really an open question. Anyone want to help? So last piece here, just want to highlight our Mill Creek study. So moving upstream, up near Logston in the Slut system. And this is just a really good collaboration between us, the Watershed Council, ODF&W, and researchers at OSU to really study a basin-wide large wood treatment and what that does to us, the salmon population, especially coho population in the basin. We always get asked, and it's an impossible answer of how many fish will this project make, and we'll never really be able to answer that. But this project actually gets us closer than we've ever been. So what we needed for this were accurate estimates of the watershed scale fish production at all life stages and long-term data. And Mill Creek set up really well because there's 20 years of all the adult coho going in and all the juvenile coho moving out from the ODFW life cycle monitoring site. Also had very supportive landowners with the tribe, Plum Creek Timber, and eventually Warehouser. And the site, basin also had very low wood volumes prior to the study, so we could really have a big impact. Just another picture of the funding for this. The life cycle monitoring in kind is what really helped us leverage this $300,000 or so in grant funding. The wood placement itself took place over 2 years, and in total we put about 700 logs and almost 7 stream miles, so treating almost the whole basin with very large wood. And here's just some examples of left pre-project, right post-project, loads of wood. No wood in South Fork, lots of wood in South Fork. And the effectiveness monitoring piece here was fivefold. So the geomorphic response, winter rearing habitat, benthic macroinvertebrate response, overwinter survival of juvenile coho, and coho smolt abundance. And we do have some good results from this. We're in year 5 of 6 of this project, but I'm focusing kind of on the people here, and feel free to contact me, and we'll actually have a workshop this summer to highlight this project out in Logston as well. So quickly, geomorphic response, Dr. Catalina Segura from OSU led this. She's had 2 master's students who've looked at water velocity and slow water habitat, which is what juvenile fish need, but then also kind of really looked closely at 10 of these log jams to see where erosion's occurring, where deposition is happening, and all these things, and really getting a picture of how these large wood structures are affecting streams. Here's that aquatic habitat inventory piece. So we're actually doing the year 5 post-project now. After that's complete, we'll be able to compare that to the year 1 and the pre-project AQI, again, working in partnership with the ODFW crew and the Lincoln Soil Water Conservation District to really see how the habitat is changing. Benthic macroinvertebrate piece, Bill Girth, Judy Lee, and some students at OSU and the field crews from Oregon DEQ have been great going out and collecting and really looking at the community composition and using a Baki design with some control sites nearby to see what's really happening with the community composition of macroinvertebrates with this big influx of large wood. Finally, the coho pieces. Chris Lorian was the original researcher who helped write this. Mike Lance and Wesley Shum have been his, have filled in for him since he left, and Eric Suring has been our big piece from the life cycle monitoring project in OSU, and then with help from Plum Creek and Weyerhaeuser to catch all these fish, tag them, and really get a lot of good data on survival. And then smolt abundance, same crew with their fish trap, catching all the smolt on their way out, measuring them. Just a ton of work to measure all these fish. A few other partners here on that project. Obviously, our funders, Stacy Pekulski and Jeff Light, have both moved on to different positions, but we're integral to this. Weyerhaeuser's been a good partner, Marianne Ryder, and more recently, Mark River. Derek Wilson, there's his name again, great watershed partner, getting work done out here, and a couple other grants from the Sport Fish Restoration and ODFW R&E. So I know I'm over, 2 more slides. Just looking ahead, we have applied for an OWEB focused investment partnership. We, MidCoast, and our partners from the Oregon Central Coast Estuary Collaborative. Fingers are currently crossed on that. We'll find out in July if we get that, but that would be 6 years of funding, up to $12 million for focused Yaquina and Alsea tidal restoration work. And we're going to have an absolute massive monitoring need tied to that. And luckily some monitoring money. So that's I think an area that's ripe for collaboration and working with folks from Hatfield and beyond to do some work there. We're expecting a lot of infrastructure recovery funding opportunities coming from the infrastructure package, and looking forward to that. And then MidCoast is going to take a really hard look at our kind of internally at our strategic planning in May, and look at what we're doing well and look at where we could do better. And that's about it. I'll just throw a couple more plugs in here. How to get involved. Donate. Obviously, we're a 501c3. So anything you donate is tax deductible. We have a lot of volunteer opportunities. We operate a conservation nursery with state parks at Beaver Creek, and most of this winter we are out planting with volunteers, and in the summer we're propagating plants at our nursery. I put the plug in there for the tech team meetings, not just coming in participating to provide input on our projects, but bring your projects for input as well. And then we do have community meetings as well every month, first Thursday of every month. We encourage you to attend those. And if you have a presentation you need to share with the public of your research, we're always looking for topics and speakers for our pretty much the same as this, 45-minute presentations with some questions and answers. Got enough plugs in there for monitoring assistance. If you have any questions at all about this or how you can get involved, please feel free to contact us. You can see my email and Trevor's email up there, as well as our office phone number. Just give us a call. Come to a community meeting, come to a tech team meeting, and we'll find a way to fit you in. Thank you. I know that was a lot.
Thank you so much, Evan. I appreciate that. For folks that are online, go ahead and put any questions you might have for Evan into the chat, or feel free to raise your hand and I can unmute you. Evan, while folks are kind of putting their questions together and thinking about it, I had a couple questions for the project that you talked about and the one that's pictured here on the slide. When was that completed? Or I won't say completed because I know it's not complete, but when did the on-site work kind of wrap up?
That was summer 2020. So not this last summer, but the previous summer.
Nice. And how about the project that you just talked about? This, I was going to ask about upcoming work that you're focusing on. Can you talk to us a little bit more about the Yaquina wetland restoration work and kind of what your vision is for that, and kind of set the stage for folks if they want to get involved? Yeah,
so the focused investment partnership, it's just a big, essentially a separate pot of money from OWEB that if we get granted, we have a kind of in on up to $6 to $12 million over 6 years, and it's focused on the Alsea and Yaquina, so all within MidCoast's range, even though we're working with the Estuary Collaborative, which has a wider geography. It's really threefold. One is working in areas of current tidal habitat, so like the Yaquina Tidal Project, where there's currently projects that we can remove dikes or take out tide gates and boost habitat that way. There's some The second leg is kind of focusing on scrub, shrub, and forested tidal wetland, so Sitka spruce swamp type habitat, and that's really informed by that Brophy report that I mentioned of that loss. And so acquisition and easements in those areas, as well as work to kind of boost those habitat types and try to restore that as a kind of piece of our landscape. And then the third leg is more forward looking and looking at landward migration zones, and where our future tidal wetlands will be, and either acquiring those areas, getting easements in those areas, or doing work now to kind of build resilience. So when the tides come up 50 to 100 years out, the vegetation is established there. There's nurse logs out there, and it's set up to kind of be more resilient to climate change. So it's kind of working both where we know the tides are now, and also more kind of looking 100 years out at sea level rise expectations. And as far as how to get involved, we essentially have a suite of projects. We put together 25 projects, again, vetted through our tech team, of kind of priorities of what to do there. And we're going to need help, with project management. We're going to need that big monitoring element. We have a big monitoring plan tied to that work that monitors the work, not just at the projects, but kind of, at different scales. So project scale, and then zooming out to whole estuary scale using remote sensing technology. So just tons of opportunities to work with us and get grad students lined up to bite off pieces of that work that's needed. And we're, like I said, we're realistic about our chances. There's 11 FIP applications, and they're hoping to fund 5 or 6 of them. So we feel we've got a pretty good chance. If not, it's been a pretty good exercise just to go through that whole project, work and all this work to kind of say what's possible and what we can do. And if we don't get the FIP, we'll still have that list to go through these, traditional funding apparatus to get this work done.
Nice. And I'll just put in a little circular plug. If anyone is interested in Laura Brophy's work, she just did a seminar for us on February 10th, talking about the past, present, and future of tidal wetlands in Yaquina Bay. And that was part of our past, present, and future Yaquina Bay mini series that we've been doing at seminar, which Evan was slightly tied into, but not quite directly part of. And that information has been kind of around the estuary management plan update that is planned, and just kind of getting that information out there. So just letting folks know, if they want to see the recording of Laura's talk, it is on the same website that I posted apparently 3 times in the chat for where our past seminars are posted. So you can watch that and learn a little bit more about what we're thinking about on the changing tidal wetlands. So Evan, there's no questions in the chat, but I just wanted to point out that you are getting fabulous presentation, Evan, and those kind of things, and virtual claps basically happening. Let's see. Yep. And thank you for your time and knowledge, Evan. So I think it was well received that you presented here. And again, I think for those folks that are still online, really some great opportunities to continue to move this work forward. As we know, it takes all of us to do it. And this group has done an amazing amount of work. So thank you so much, Evan. Anything else you want to say? Last little bits here.
I just want to thank you, Cinnamon, for the opportunity, and thanks to everyone for listening. And Cinnamon and I were talking a little bit before everyone got on about some collaboration between our groups, and we, like I said, we do our community meetings too, and we're excited to engage more with the Hatfield community as much as we can, especially looking forward to this hopefully post-COVID world where we could all see each other in person too. And just really collaborating. We know it's just an absolute brain trust down there at Hatfield, and we're eager to start the conversation with all of you and get you all more involved in our work that we do out here.
I think the brain trust is on both sides. I think you have an amazing team to get the work that you do
Absolutely.
done.
Absolutely.
A couple more. Great job. Thank you very much. Good job, Evan. So I think that's what we're getting. So for everybody that joined us online, thank you so much for being here and spending your afternoon with us. Much appreciated. And hopefully you'll be able to join us again next week at our seminar, same place, same time. And Evan, thank you again so much for being here and being with us today. And hopefully we'll be able to see you face to face sometimes in the future, and the collaboration we will continue.
Perfect. Thank you.
All right. All right, everybody, until next time. Thank you so much. Bye now.